All right, hey y'all.
Hi.
Today's objective is solving a system of equations by elimination. We've gone over graphing, we've gone over substitution, and so this is my favorite, at least, elimination. So to eliminate means to get rid of or to do away with. So we're going to eliminate one of the variables, either the x variable or the y variable, by adding the equations. And you must have a positive and a negative coefficient. And a coefficient is the number in front of the variable. So to do this, we're going to look for a positive and a negative coefficient
That is the same number.
that is the same number, the opposites, in front of the same variable. So we want to focus on either the x's or the y's. And so in this example, we have a system of equations. 5x minus 6y equals negative 32. 3x plus 6y equals 48. So you should see very quickly a set of coefficients that are opposites. And they are right here. We have a negative 6 and a positive 6. That is exactly what we're looking for. That is our goal, to have a positive number and a negative number. So we can eliminate them by adding them. So you're going to put an addition sign. And we are going to add these equations. Now, what happens when you add a negative 6 and a positive 6? We know that if you put together a negative 6 and a positive 6, those are going to eliminate because they add to be 0, which that is the whole goal of elimination. We want one of our variables to eliminate. We want them to go away.
And so then you're going to add your like terms. 5x and 3x add up to equal 8x. And as Ms. Handler just said, negative 6 and positive 6 would equal 0, so they cancel out. And then bring down your equals. Negative 32 and 48 add up to equal 16.
And just what Ms. Barnes did, she added them vertically. She added the x's and then she added the numbers. The y's have eliminated. You are going to solve for x. Divide both sides by 8. And x equals 2. 16 divided by 8 is 2. And we have talked about, this is not our solution. This is half of our answer, but we need an ordered pair. So once you get the first letter, x equals 2, you're going to plug it back in. You can pick either of the equations. We'll just pick the top one. So instead of 5x, I'm going to plug in a 2 for x. Minus 6y equals negative 32. So I'm taking my solution, x equals 2, and I'm plugging it back in for the x value. Now I'm going to solve this equation. 10 minus 6y equals negative 32.
I have to get rid of 10, so subtract 10. Now 10 minus 10 equals 0, so it cancels out. So you have negative 6y equals negative 42. And so divide by negative 6, and y would be positive 7.
And because I have now an x value and a y value, I can put them together for my final solution, which is 2, 7. So that is an example of elimination. You're going to eliminate one of your variables, solve for whatever you have left, and then plug it in.
Alright, so we're going to do example 2. You have two equations, negative 2x plus 9y equals 1, and then positive 2x plus 3y equals 11. So I'm going to check both equations, and for the x's I have negative 2 and positive 2, and for the y's I have 9 and 3. Well, the purpose is to find the opposites, and so right here negative 2 and positive 2 are opposites of each other, so when I add these together, they're going to cancel out. So negative 2 plus 2 equals 0, so x's go away. Then I'm going to add the y column, 9y plus 3y. Oops. This part needs to learn how to add. It's 12y, and 1 plus 11 is 12. So then you're going to solve for y. Everyone should know they should divide. And so y equals 1 for this system. Then you're going to take the variable that you got, y equals 1, you're going to substitute 1 in for y. I'm going to do the second equation this time since Ms. Handler did the first one. So 2x plus 3 times 1 equals 11. That's going to be 2x plus 3 equals 11. So 2x, oh, I'm sorry, let me show my work. My minus 3.
You subtract 3 on both sides. And 2x equals 8. 11 minus 3 is 8.
And then divide by 2. So you have x equals 4. So I have x equals 4, and I have my y equals, the answer would be, remember x comes first, is 4, comma, 1.
Alright, so example 3, x plus y equals 30, x minus y equals 6. So I'm looking for the same coefficient but opposites. Now in this one, if there's no number, remember you can put a 1 if that helps you. And I have 1s here and I have 1s here. But to use elimination, you want them one to be positive, one to be negative, so they will eliminate. And it's right here in the y's. So I see I have a positive 1 and a negative 1. My y's are going to eliminate, and I'm going to add my equations. 1x plus 1x is 2x's. 30 plus 6 is 36. I have to divide both sides by 2. And x equals 18. Now don't get tricked because you want to try to eliminate the x's, because remember you have to have a positive and a negative. Once I find my x value, I'm going to plug it in. So I'll just plug it into the top one. We have 18 plus y equals 30. So we would subtract 18 from both sides, and y equals 12. So then to put it together as your ordered pair solution, Ms. Barnes said your x comes first, so this solution would be 18, 12. And that is the intersection, that is the solution to the system of equations.
Alright, so sometimes all the problems don't have opposites. And in that case, what I like about elimination is that you can multiply one or both of the equations to make it work for you. So let's look at example 4. We have 5x plus 7y equals 77. And then 5x plus 3y equals 53. Now when I look at both equations, I see that the x column has both 5's for the coefficient, but both of them are positive. I need one of them to be negative. So when that's the case, you can multiply one of the equations by -1. You have to multiply everything. So I'll do the top one. You multiply everything by -1, and what happens is -1 times 5x now becomes -5x. -1 times 7 becomes -7y. And -1 times 77 becomes -77. So that's your new equation. Now when I look at these two equations, can you eliminate? And that answer is yes. This one is positive, and this one is now negative.
And it's really important, just like what Ms. Barnes did, that you rewrite that equation, because now you need to use the blue and the black equation. You don't use this top equation now to eliminate. You have to use the new equation that you just wrote.
So now we're adding everything together. 5 plus -5 equals 0, so that cancels out. 3 plus -7 is -4y. And 53 plus -77 is -24. Alright, then you're going to divide by -4 on both sides. So we get y equals +6. Alright, then we take this answer, just like we did before, and we plug it back into one of the original equations for y equals. So let's do the second one. 5x plus 3 times 6 equals 53. Well, 3 times 6 is 18. You're going to subtract 18 on both sides. You get 5x equals 53 minus 18 is 35. And then you divide by 5, and I don't know if y'all can see this at the bottom, that's what I'm talking out loud. 35 divided by 5 would be x equals 7. So again, just because you got y first does not mean it comes first in your coordinate. X always comes first, so 7, 6 is your final answer.
So in example 4, we have the same situation. 9x minus 3y equals 24. 7x minus 3y equals 20. we should see, hey, we have 3y and 3y, but both of these are negative. And you cannot eliminate, you can't add them together to get 0. Negative 3 plus negative 3 is negative 6. But we want to multiply one of these equations by a negative 1. So, going to multiply by negative 1, and when you do that, you end up changing all of the signs within the parentheses. So, negative 1 times 9x, negative 9x, negative 1 times negative 3 ends up going to be a positive 3y, and negative 1 times 24 is negative 24. Now I can add them, and I don't really want to pay attention to that top equation anymore for right now. 7x plus negative 9x. Oh wait, first I want to eliminate. Now I have a negative 3 and a positive 3, so I can eliminate the y variable. 7 plus negative 9 is going to give me a negative 2x. 20 plus negative 24 is negative 4. And then I'm going to divide both sides by negative 2, and x is going to equal 2. To find the rest of our solution, we plug it back in like we've been doing. I'm going to plug it into this blue one right here. 7 times 2 minus 3y equals 20. 7 times 2 is 14. You need to subtract 14 from both sides. And I'm going to come right here. I get negative 3y equals 6. Then we need to divide both sides by negative 3, and y is equal to negative 2. You find your x value, you plug it back in to find your y value, and now I have my two values, so my final answer is 2, negative 2.
Alright, so we have 2 questions for you guys to try. Try these at home in your notes, and we'll discuss them in class tomorrow. Or you want to do them now?
Well, it's 12 minutes, but do you want to? Okay. All right. Try it.
Try it. Bye.